Acceleration. Acceleration is the rate at which a body's velocity changes. Acceleration is the measure of how quickly a system gains or loses speed, i.e., how velocity changes. Mathematically, or in terms of calculus, acceleration is the first derivative of velocity with respect to time, or the second derivative of distance or position. Given the function for velocity with respect to time t of v of t equals ds dt, or velocity is equal to change in position s divided by change in time ds over dt, the body's acceleration at time t is a of t equals dv dt, so change in velocity over change in time, or second derivative of position. Or, in a different format, we have a of t is equal to v prime of t, or the second derivative of position, so s double prime of t. Example. Calculate acceleration based on the following function of velocity. V of t is equal to 3t to the fourth plus 5t squared minus 13. So, we want to calculate a of t. We know a of t equals the first derivative, or v prime of t, first derivative of velocity. So, v of t is equal to 3t to the fourth plus 5t squared minus 13. V prime of t, using the power rule, 4 times 3 is 12t, 4 minus 1 is 3, plus 2 times 5 is 10, 2 minus 1 is just 1, and because there's no t here, a constant derivative of a constant is 0. So v prime of t equals 12t cubed plus 10t, so a of t is equal to 12t cubed plus 10t, since acceleration refers to the derivative of a function of velocity. A of t equals v prime of t. Another example. Calculate acceleration based on the following function of position s. S of t equals 4t to the fifth plus 2t to the fourth minus 2t squared plus 3. So, what do we need to do? Well, s of t, derivative of s of t equals v of t. So that's the first step. So v of t is equal to 20t to the fourth plus 8t cubed minus 4t. Derivative of a constant is 0. So now we have velocity. Like in the previous example, the derivative of velocity is equal to acceleration. So a of t equals 80t cubed plus 24t squared minus 4. So in looking at this, we can see that, as in the definition, a of t is equal to v prime of t, which is equal to s double prime of t. Since we took the derivative of this function twice, so s double prime of t is equal to a of t, we just used the intermediate step of turning the position function into the velocity function through differentiation, then differentiating v of t to yield a of t.